Hi everyone, Mr. McIntyre here. This is 2.7, it's our last section of Module 2, and we've been talking a lot about equations. Today I want to talk to you about formulas, which are kind of the same with a couple little differences. So let's talk about those differences. Well, what is the difference between a formula and an equation? So I said a formula is like an equation. It's got an equal sign in it. It's got two things that are equal. Here's the couple main differences between just an ordinary equation and a formula. Number one, in a formula, your variables usually have real life meaning. So I said, like, you might use V for volume, T for time, A for area, things like that. Whereas in an equation, we usually just say X. X is just a number I don't. It doesn't really mean anything, it's just solve for X. But in variables, or in formulas, the variables do usually mean something. Number two, most formulas have more than one variable. In fact, most formulas have a lot. Sometimes they have 3, 4, 5, 6 variables. So those are the two main differences. The variables mean something, real life, and you usually have more than 2 or 3 variables in each one. So let me give you an example of a formula. Right here, we have capital V equals, and then that first symbol there, I think you guys have probably seen it before, but in case you haven't, that's a Greek letter pi, and it represents a number in geometry that's about 3.14. So we have V equals pi, then we have R squared, then we have H. So there's 3 variables in this, V, R, and H. Pi isn't a variable, it's a number. But there's 3 variables, and there's also an exponent. So this is kind of a complicated formula. This is for the volume of a cylinder. So capital V represents volume. Remember, the variables usually mean something. V stands for volume. R stands for radius. And I'll show you a picture in just a second where you'll see that. And H stands for height. V for volume, R for radius, H for height. Each letter is the first letter of the word it represents. So here's a picture of a cylinder. A cylinder is like a can shape, like a soda can or a soup can. It has a circle on top and bottom, and then it's straight along the sides. So that H is how tall the can. If you think of it as like a soup can, H is how tall it is. Is it 4 inches tall? Is it 10 inches tall? Is it 20 feet tall? How tall is this cylinder? Now, radius is radius of a circle. So the radius is this line right here. You can see it. I'll highlight it in red to make sure it stands out. That's the radius, meaning if I took that can shape, we're kind of looking at it from the side right now, but if I looked at it from the top, it would be a perfect circle. R means the radius of that circle. So the volume of the cylinder is the number pi, which is about 3.14, times the radius squared times the height. So the main use for formulas is evaluating. Like if I had a cylinder and I said the height of the cylinder is 6 inches and the radius is 2 inches, tell me the volume of this cylinder. You could say pi times 2 squared times 6. You could maybe grab a calculator and type it out and tell me what the volume is. But that's not really what we're doing today. What we're doing is working with formulas. So what if I wanted a formula for not the volume, but for H, for the height of a cylinder? The way you would get that is the same as we've been solving equations all module long. You guys can use inverses to cancel things out, basically isolate the H, and you have an equation for H. Isolate the R, you have an equation for R. Isolate the V, which is already done for you, you have an equation for V. So within a formula, if you isolate any one of the variables you see, you then have a formula for that. So let's do the one I just talked to you guys about. Let's come up with a formula for the height of a cylinder, H, which means I'm basically asking you to solve this equation for H. We want to isolate H. So let's do that. I'm going to recopy the formula real quick. volume equals pi r squared h. And I want to isolate this h right here. Now remember, to isolate means to get rid of everything around it. So what I want to get rid of is this thing right here, this pi r squared. So I think, okay, now what's happening? What's the math operation here? Am I taking my height, am I adding pi r squared? No, I don't think so. I would see a plus in the middle. What I see is pi r squared h all stuck together. And remember, in math, stuck together is multiplying. So if I wanted to cancel out multiplying, I would use dividing. So what I'm going to do, I'm going to divide by pi r squared. Then of course, rule number 1 for equations, anything I do on one side, I have to do on the other. So what I divided by, pi r squared, cancels. I have isolated h. Now just leave what's left on the other side. You don't need to try and, like, there's no numbers in this, so you can't actually grab a calculator and divide. What you have now is a formula for height of a cylinder. The height of a cylinder is volume divided by pi r squared. And that's what we're doing today. We're taking a look at formulas with more than one variable. We're solving them just like you solve equations, but it's a little trickier because your answer isn't a number. Your answer is a new formula. So let me do one more example with you guys. This one is not as real life meaning. I just made one up with p's and q's in it. So let's say we have this formula, 3q minus 4p equals 12. And let's say we want to write a formula for p, or solve this equation for p. So this time, that's the one I'm trying to isolate. And let me recopy again. I should have, when I typed it up, I should have put the equation underneath it so I didn't have to rewrite it. All right, so I want to isolate p, which means I want to get rid of everything. I want to get rid of everything on the same side of the equation as p and move it to the other side. So let's start with that 3q. I'm going to get rid of the 3q. Now that's positive, so I'm going to subtract to get rid of it. Anytime you have a positive number or a positive term, you can subtract to get rid of it. So I'm going to do a minus 3q and a minus 3q. 3q minus 3q is gone. Those cancel. The rest, the negative 4p, drops down. And then you have 12 minus 3q. Now that does not equal 9q. Those are not like terms. You can't combine them. So make sure 12 is just a number. I can add a number to it or subtract a number from it, but I can't add a variable to it. Same thing with the 3q. It has to be like terms. If I have another q, I can add to it. But a 12 minus 3q, just leave it as 12 minus 3q. Okay, almost done. One step left to finish solving for p. I need to get rid of the negative 4. Negative 4p is multiplying, means negative 4 times p. So to get rid of it, I'm going to use a divided by 4. And I'm going to divide both sides by 4. Now when you're dividing both sides of an equation by 4, I can either do it like this, divided by 4, or, and I'm actually going to change that, what I like to do is just divide each side. It's actually a negative 4, not a 4. Divide each side by negative, or divide each piece by negative 4 separately. Now this should be my final answer. The negative 4 cancels the negative 4 and just leaves p. Now let's simplify each of these. The first part is 12 divided by negative 4. That would be negative 3, because 12 divided by 4 is 3. And a positive divided by a negative is negative. Now the second part of my answer I can tell is going to be positive because it was a negative divided by a negative. You have negative 3q divided by negative 4. Negative divided by negative is positive. Now what I'm going to do, I'm actually going to leave a little space there, but I'm going to leave the q in my answer, and then I'm going to reduce that. Just leave that as a fraction. And in fact, it can't be reduced. So I'm just going to call it 3/4. So that would be my answer. That's my formula for p. Negative 3 plus 3/4 q. And that's what you guys are doing today. We are solving, instead of solving equations where it's just solve for x, it's going to be solve a formula where maybe you have to solve for P, but you leave Q's in your answer like we did. Or maybe you're solving for the height of a cylinder, and you're going to have V for volume and R for radius in your answer, like our first example. So think about that. We're solving formulas, we're creating new formulas basically by isolating variables within formulas.